Paula used to be the head of the department at University of L'Aquila in computer science, and now she's the dean. I've known Paula for a very long time, so I don't keep track of her career anymore. She's been working in a variety of areas from logic program to software architecture, and is very keenly interested in applying formal techniques. And she's going to talk about food and computer science and composing dependable food systems.
So actually, thank you, Paula. So actually, from the magic word Cherry described, we will go to the boring engineering word, because my talk will be, hopefully, in the direction of providing some kind of, at least thinking, if not methodology or tools, to improve the way we can actually make good meals or a good dish. Let's say, what does it mean? And thank you. So on composing dependable food system, of course, now I'm playing a game which comes from my background, as many of us have been doing. So my background is, as Bala was saying, basically software engineering in the large. So I've been working on software, and in particular software architecture as a specific way of looking at software, or at the structure of a software, or a piece of software. And the focus is my focus on the construction of complex systems, and these systems, I'm not only concerned in building a system, but actually in building a system that shows some kind of qualities. So this calls for the dependability, but I will explain in a while. And as everybody knows about it, in any engineering discipline, this involves a process dimension, the way you actually, the set of activities that you carry on to reach your objective, and the product itself that shall, at the end, eventually exhibit some certain number of qualities. Now here, I will play this game, which is basically common to any engineering discipline, not only software. It's just by chance that I was working on software. And I will talk about food systems. And what do I mean? I think that gastronomy and cooking, and actually few talks this morning addressed exactly the same issue, are about composing basic elements, ingredients, if we want, in a good way. Whatever it means good. We will try. I will try to give my contribution in this direction. And this works both at the process and at the product level. So I will try to draw this, parallelism in between food systems and software systems, and especially talking about and using this notion of software architecture that I will explain in a while. And what is this for? First of all, because I would like to again stress the difference in between process and product, which, of course, it emerged in many talks, but it has to be definitely separated. And the other issue that I want to bring into discussion is about compositionality. Actually, what we do is that we compose. We compose things, and we rely on the output of other compositions. And then the third one is that I would like to be able to say that we should be able to prove properties about the product just looking at the way we are composing things, so just looking at the architecture. And last, I would like to offer a different perspective of looking at food systems and meal. So, this is something that I already said, but if you take a standard definition of software engineering, it's about software. Software are computer programs and their related artifacts, and engineering is the application of scientific boring principles in the context of practical constraints, even more boring and less magic than the game word, but maybe practical. And of course, you can exactly replace software with food, elements for, computer programs, and engineering remains exactly the same. So the objective is still the same. Try to have a principled way of producing what we want. And if you look at what is defined as a process, this is the usual set of activities that everybody goes through when tries to define a precise methodology to achieve a goal. So you start from a specification, then you do a design, your blueprint of stuff, then you carry on a validation, and then eventually you go through evolution and maintenance. And if you play this with food, it's exactly the same. I mean, you start from your objective, it's the specification of a desired meal or dish. And then you give a description of how it has to be done in terms of pieces. And then you would like to validate your result if it actually responds to your desires. And then, again, you have to carry on, or to think about evolution or maintenance. So, what is a software architecture? And just to give a little bit of my background. Basically, it describes, given a software system, it describes the gross-grained logical structure of the system in terms of subsystems, components, and the way these components interact. And this is an example in our setting. So this is a lasagna. Alla bolognese. And actually, this is a layered architecture. So it has a certain number of components, which are the layers of pasta. It has cheese, that might be mozzarella or whatever you want. It has Parmigiano, Reggiano. And, these basic components are actually glued together through what I call connectors. And that it actually makes the interaction among these components worthwhile. And in this case, we have the ragu, and also the oven. So just let me introduce a little bit of a hint that goes in the direction of molecular cuisine. Because, the oven actually, and it's the cooking process, it's a connector and acts as an interaction mechanism in between the different components. So in the world of software architecture, we use to differentiate among different levels of abstractions of the system. So we used to talk about software architectures, really the components and the connectors, so our lasagna alla bolognese. But we also talk about architectural styles. Somebody this morning was actually talking about styles in mixing flavors, no? And architectural styles in our setting is a family of similar systems that provide common vocabulary for components and connector types, and provide a set of constraints on how to put these things together. And if we think in this setting of cuisine, we can talk about a layered structure. And you see that a layered structure emerges in many, many different dishes. The lasagna alla bolognese or melanzane alla parmigiana, moussaka. You have many different dishes that actually are built using this structure. And it's not by chance. It's not by chance. It has a meaning, the fact that we are putting together things in this way. And then we have this notion of architectural patterns in the software setting. Architectural patterns are well-established solutions to architectural problems. They give description of the elements, relational types, together with a set of constraints on how to solve the given problem. So, for example, if you talk about a balanced diet for a marathon runner, then you will, and you type diet for a marathon runner on the web, on Google, you will get many different answers. And these are all patterns that are providing you with guidelines to build a diet which fits your problem. And it's given in terms, you see, of components and quantities of these components. So, certain number of calories coming from carbohydrates, and then calories from fat, and calories from proteins. So let's go to dependability. Dependability in software is very well defined, and actually it's defined as the trustworthiness of a computing system which allows reliance to be justifiable placed on the service it delivers. And normally, this notion of dependability, which is a complex notion, is not just one dimension, it's multidimensional, has many attributes, among which we have reliability, availability, security, safety. Now, what is interesting is that in order to achieve dependability, it's in software systems, like in other products, you need to focus on the process. It's not just enough to focus on the product, as you might imagine. And even in this case, this perfectly applies to our food system. No? I mean, we need to focus on the way the food is prepared and is processed in order to assess some qualities at the end. And in our setting, this means that there is a very strong prerequisite for this, which is traceability, food traceability. Now, these are all elements that I will try to put together at the end. Now, what is my focus? My focus is on what I call the food systems. So, I mean, it's not single ingredients. So dishes or meals, but now I will talk only about dishes. And dish is a composite made out of a set of ingredients suitably connected. And we have main components, as we have seen for the lasagna. Plus, we have this glue, these things that put things together, that allows these basic components to interact. And these are what I call the connecting elements, inspired by the software architecture word. And for example, the olive oil and or the cooking process. And of course, a meal is something more complex because it's a set of dishes into a proper sequence. And proper, it's not random. It's proper. I mean, but we do not have time to address the meal issue. I mean, it's just scaling up. Now, just few examples for you. I mean, this is a sort of caprese salad. I mean, olives are not in the caprese salad. I mean, this was the best I could find on the web. So, I mean, in terms of ingredients, what we have is mozzarella, tomato, basil, and the olive oil, which actually is a connector. So this is why it's in red. So it's what glues these things together. It's the way these different ingredients can interact. Now, look at this one. This is another one. This is called, I mean, these are friselle. I don't know how many of you are familiar with friselle. Friselle is dried bread. And friselle with tomatoes and mozzarella and basil. So again, I have the same kind of ingredients. So mozzarella, tomato, basil, plus this friselle, which is another component, plus olive oil. And here I have also water, which is a little bit, it's a connecting element. Because if you do not put some water on the friselle, then nothing will interact. Friselle have to be a little bit humid, otherwise nothing will interact. You would not be able to get the final dish that you want. And then look at this one, pizza margherita. Again, same kind of ingredients, no? So we have mozzarella, tomato, basil, olive oil. Now we have pasta, I mean, it's dough for the pizza, with yeast dough for pizza. And we have to add the oven, because the cooking process of all this stuff, it's what will bring you to the result. So few considerations about that. So the first dish has simple components plus a connector, which is the olive oil. The second dish has the same set of components plus the friselle plus water. The third dish has the same simple components plus a subsystem, which is the pasta. And the same connector among all of them, which is the olive oil, plus this computing resource, the oven, that acts as a further connector by cooking everything. Now, from the fact that we have, these three different dishes, actually very different. If you taste them, they're quite different. Can we, and they use the same components and connector. Can we draw some conclusion about potential similarities? of the subsystems that they use in terms of the overall final quality of the dish. I do not have an answer here, but I suspect that there should be an answer. And so maybe that we could say that attached to the subsystem, which is made out of the main ingredients plus the olive oil, we can attach a description in terms of a subnet of flavors as described in the flavor subnet by Sebastian and YY? Maybe. Second consideration, I mean, the caprese salad, friselle, and pizza margherita are architectural models of the respective dish. So they describe the components, how this component interacts, and how the components are topologically related, and which kind of connectors is used. So the final dish is actually obtained by providing concrete instances of these components. No? And this makes a difference. So it's not exactly the same. I mean, if you use mozzarella di bufala, cherry tomatoes, extra virgin flavored olive oil, wooden oven, and for example, myself, without any modesty, because I make a very good pizza, you get a certain kind of pizza. So which kind of qualities can we attach to the architecture and not to the instances? This is something which I think might turn out to be useful, because in practice, this is what we actually use. We use the knowledge of something which is aggregated, and that we attach to this knowledge some kind of taste or flavor or whatever. So at the end, no, if we want to talk about architectural qualities, no, at the end, I mean, bad or good, a pizza is a pizza. I mean, if I tell to anybody of you what is a pizza, you will try to tell me what is a pizza, no? So how can we formalize what is the invariant property that characterizes the architecture of a pizza? I'm not talking about the instance, I'm talking about the model. So for sure there are structural properties, and in one talk, I think the talk this morning about the flavors, there was exactly the same kind of conclusion. I mean, for sure there is a notion of structure. I mean, when we talk about gastronomy, we talk about cooking, the way we put ingredients together topologically has a meaning. Not only a visual meaning, it has a tasting meaning. So there is a structural dimension, but there is also a behavioral. Let me say behavioral. I don't want to say taste. I mean just behavior. The way, the final quality of this product. So we can think that we might start from the behavioral properties of a single components in terms of their chemical structure, like for example today was shown. Or basic chemical structure. And then by considering the way we are connecting these components together and the kind of interaction mechanism that we are using, we might deduce that there is an overall characterization of this dish. So, I mean, here I'm obviously referring to molecular gastronomy because it goes deeper, no, into the characterization of the qualities of your dish. So, but what I would like to conclude is that, I mean, basically then, I mean, there are structural properties and behavioral properties that we might want to characterize in a meaningful way, like this morning we were looking at. So, I mean, again, I mean, it's the structural properties are based on the structure. So, for example, I mean, we had this flat layered structure for pizza, but I mean, it's the same if I talk of a pasta, it's the same if I talk of a panino. I mean, it's clear to you a panino what is, I mean, what is its structure. And the behavioral properties can be characterized in many different ways. It can be the chemical structure of the basic flavor. It can be the calories. It can be the carbohydrates. I mean, there are many, many dimensions in which we can characterize and attach to a single product. And of course, I mean, what I'm interested in, I would be interested in trying to characterize the combination of flavors. So if we put together mozzarella, tomato, basil, and olive oil, there should be a disciplined way of quantitatively characterizing what this combination essentially means in terms of the quality of the assembling. But then, so what? This is the question, everybody. So what? What is this for? So basically, I mean, what I think is that this kind of reasoning, this architectural reasoning, can be an abstraction that is useful or can be useful in many of the problems that we have been seeing so far today. For example, in search. I mean, you might want to search not by ingredients, not by group of ingredients, but you might want to search for patterns of an architectural combination. Also, if it is quantitatively defined. Actually, when you look for a pizza, you are looking for a pizza recipe. You are looking for something like that. It's good for reuse, because what I'm thinking of is that, I mean, in defining recipes, you can reuse this kind of patterns if we have a body of knowledge about well-known, well-experimented, well-certified patterns. And it helps in the creation, development of new dishes. So now I'm not talking to the extra gourmet chef. I'm talking to normal people, and I'm talking to what this kind of abstraction, if implemented, could bring to everyday cook. There is another issue. I mean, the idea of reusing patterns is more online with our time. So our time is a time, in our ordinary life, is a time in which we actually, even when we cook, we assemble things. We assemble subsystems. It's very rare that we do everything, from the dough to, I don't know, I mean, certainly not the mozzarella, no? But for everything. So we are assembling things. So we are working more in a component-based framework. So it would be useful to have a characterization of a recipe at the level of components and subsystems. And the architecture can be a means for achieving quality assurance. So for, certify certain quality of an aggregate of a subsystem. Now, I mean, if we talk about dependability in food systems, I mean, of course, we talk about, I have to show this because it's too nice. Of course, we talk about the quality of a single product. I mean, but this has to do with the production process plus intrinsic qualities. So, for example, if you look for mozzarella di bufala, I don't know if we will get anything here. We will, and you get a chance, which is not obvious, to buy a mozzarella di bufala coming from this place, which is Tenuta Vannulo in Cilento. Then of course, I mean, here, I mean, the quality is certified because you are exposed, when you buy the mozzarella, you are not only exposed to the intrinsic value of mozzarella, but you are also exposed to all the production process. So you can actually follow all the production process. Now let me go back. And of course, I mean, there is the quality of the composite. And again, this has to do with the production process, but the production process this time is under your control because it's actually the cooking process. It's the way you are developing it. And it's important to discuss and to know about the achieved qualities that emerge from, putting all these things together. Now, I mean, again, how can we assess qualities? Architecture can help in this, provided that we know known properties of the components. So, I mean, it's not difficult to think, but if you are able to start from a known quality of the components and you are assembling the component in a well-known way, then you can actually provide, by definition, I mean, thanks to the way you are putting things together, the quality of the resulting system. So just a few words about recipes, because this goes also in the direction of recipes, or offering something at the recipes level. So in Italy, the first widespread cooking manual was actually Pellegrino Artusi. It's 1891. This was a very respectable guy, and he wrote this book, The Science of Cooking and the Art of Eating Well, when he was 71. And it was a huge, I mean, actually, he paid for the first edition himself. And after 2 years, I mean, he started selling a huge number of volumes compared to that time. And it's very nice because, I mean, in this book, recipes are described in a very flourishing Italian way and making a lot of references to ordinary life. And of course, making references to the process that at that time was in place for cooking and for achieving products. So what about our time? I already said, I mean, our time is not Pellegrino Artusi's time, no? It's the internet time. It's the time of a lot of so we can actually evolve from the level of details of description of those recipes to something more evolved. And here I like to make a reference to Pilar's and talk that was exactly, I mean, in their talk, there was this stress on El Bulli language, no? Which actually embeds some of what I'm saying, because it lifts the level of abstraction of the language, attaching to words more complex meanings, more complex semantics, no? So, so if we look at architectural language like a way to describe recipes, then we would like to have a language to describe components, connectors, and execution constraints. We would like to have a property language to describe the relevant properties of the components and of the composite. And of course, here we have to find a way to categorize the quality, like it works in panel tests. For example, for olive oil and for this. So you have to provide a mean to give to subjective judgments some kind of objective quality. And of course, we need means to analyze, test, and monitor these qualities. And here, I think that social networks and this internet scale potential word can help in doing this. Just the last slide on challenges. So objective qualities versus subjective ones. Objective qualities, I mean, we know that we can do a lot. No? I mean, the talk about the flavors and genomic structure of ingredients and so on and so forth help in this, for sure. But then there are these subjective qualities that we need to make objective. And here I think that gastronomic online social network can help, but only if they rely on well-established or well-defined categories of qualities. Not just, very good, very bad, yum, yum. No, I think that you need a little bit more rigorous way of characterizing the qualities. Okay, define meaningful architectural patterns. Okay, lasagna, layered structure, pizza, panino, all these, it works. But it would be very interesting to categorize the interplay, for example, with spices with other ingredients. Again, we had this a little bit on the talks this morning. But how do we make this body of knowledge useful for other people? How do we express it in a way that it can be reusable? So, I mean, saffron, does it work with everything? Does not? Which kind of, how does it integrate with some normal ingredients? And this would be very helpful, I think. And again, I mean, define the food qualities. And here, somebody else said it this morning. I mean, actually, in recipes, usually, all the senses, all the 5 senses are used to describe recipes. From sight to hearing, crunchy, to smell, to taste. I mean, one of my worst failure was in trying to make some kind of biscotti that my husband's mother was doing. And the failure was about the density of a dough, which I missed this element. And, and that's something that. OK, and more next time.
Thank you very much. I thought I just had lunch, and I'm already hungry for pizza. So. Any questions? Yeah, go ahead, Jerry.
Yeah, I have a question. You started off showing lasagna and talked about how moussaka has a similar structure. And I'm thinking about tortellini, the common structure of
stuffed the pasta.
Pierogies and
ravioli.
But it goes across cultures, like wonton and dumplings. And so my question is, do you think that the architecture is humanly innate, or is it transmitted across cultures, or both?
I think it's both, but I mean, for sure it's transmitted.
Yes.
For sure it's, and it's the reuse of combination patterns.
Yes.
So, and that's, so.
But where does the proto-ravioli come from?
The proto-ravioli, I don't
Proto
know. Maybe in Emilia,
Tuscany,
maybe,
yeah.
or maybe China. Maybe China. Okay.
Other questions? Yeah, Mark?
I would expect olive oil and water to be their kind of own distinct components. Like they have flavor and fine structure, but the techniques being the connectors. I'm just wondering, the idea of the connector as you present it, is it a question of it being in a liquid state, or of it being soluble for flavor compounds as a vessel for taste?
Let's say that this was my choice.
Sure.
No? But because obviously in food systems it's not that clear. We might think of a cooking procedure as an interaction mean, for sure, no? Because if you melt things and then it's, but I think that olive oil can actually produce interesting interactions among the different ingredients. And it can, people say that some kind of olive oil can actually, esaltare, how is it? Can actually let the taste be more, predominant or less. And so I think that it works more as a connector. But
so
let's talk about yesterday evening, the tasting, And I found very unusual that a Spanish cook was using sauce as the connector for so many tasting.
So would butter be a connector?
Butter be a connector.
Sure.
I would for sure say that it's a connector. Yeah.
Okay, thank you very much.